Roads, bridges, airports, highways, dams, and skyscrapers all contribute to the built environment around us. Superhighways and long-span bridges create massive road networks that we rely on to take us to and from our jobs, schools, and places of interest where we conduct business and other important transactions, educate, invent, innovate, and govern in beautifully designed and constructed tall, long, and wide buildings. Beautiful structures around the world, such as the Burj Khalifa in Dubai, the Lotus Temple in India, the library at the University of South Korea, or the Rion Anturian Bridge in Greece. Locally, some of our architectural marvels include the Hyatt Regency and Conference Center, the Northern Academy for the Performing Arts, or NAPA, Savannah East, or the Queen's Park Savannah, which is known as the largest roundabout in the world. Every year, hundreds of civil engineering projects of various sizes are executed in Trinidad and Tobago, contributing to the industry sector 48% GDP allocation and employing 20% of the country's labor force. One such project is the San Fernando North Community Center located in the southern part of the island. The various stages of a project such as this includes design, approvals, site preparation, earthworks, substructure construction, superstructure construction, finishes, and handing over. Once all necessary approvals are obtained, the project is tendered out where contractors are invited to tender through open tendering, selective, or negotiated tendering. For government projects such as this, however, tendering is usually done via open tendering. The successful contractor will then sign a contract prepared according to FIDIC guidelines and works can start. Heavy equipment such as excavators and bulldozers are mobilized by the successful contractor to clear the site of topsoil and any flora such as overgrown bushes and large trees. After this crucial step, the construction team, which may include but not limited to land surveyors, civil engineers, structural engineers, project managers, quantity surveyors, site foremen, skilled and unskilled workers, along with the contractor, moves onto the site to begin the building construction.
Reinforcement for a strip footing already fabricated, just waiting to be installed.
The ground is then excavated. After excavation, a sand blinding is laid. Then a 6-inch concrete blinding is also laid above that. The rebars are then set within the excavation and formwork placed around it. Concrete can now be poured. This site is greatly advanced, so these works will not be able to be seen.
In front of you, you have a retaining wall, and if you look closely, you can see part of the foundation exposed. Here we have a isolated column with a isolated part footing down below if you look closely. Additionally, there are several types of shallow foundations. You have the most common, which is the strip footing or spread footings, which typically runs underneath a wall. And then you have the combined footing, which sometimes would consist of a strip footing as well as an isolated footing. Now what happens is the strip footing would run continuously throughout the wall, and where you have a column along that strip footing, you would have a deeper or wider footing in the area of that column so that it'll carry the load to the surrounding soil. And other than that, you have the isolated pad footing, which is if you just have a single column or member on a piece in your building footprint, you just have one isolated pad, so to speak, or one isolated foundation just underneath that column. And lastly, we have the raft or mat foundation, which is a type of foundation that is around the entire footprint of the entire building. So with this type of foundation, it would take longer because with the raft mat foundation, you are not allowed to pour the foundation, then stop, and then pour the top of the slab. All that has to go in one. So again, as you can imagine, that'll incur higher costs than a spread footing or an isolated pad footing. So typically in construction, the spread footing or the isolated pad footing would be your cheapest option for a footing. For this particular project, a combination of strip footings and isolated pad footings were used, as it was the best foundation for the project. And if you look closely in front of the beginning of the retaining wall out front, they would have saved a tremendous amount of money on excavation as well as concrete by the use of what is called a step footing. What a step footing is instead of having the entire foundation at one level, at the lowest level, what you would do is, as the ground or property slopes, as can be seen in the video, you would have a section of the wall footing, and then after that you would step it down until you gradually get to the lowest point. By doing this, you would save time as well as money on excavation and concrete and the actual foundation stem wall, because the amount of wall between the top of wall and the top of footing would vary instead of just one constant depth throughout the entire length of the wall. Once the concrete is placed in a wall form or slab, it will need to be vibrated or consolidated by some means. In a wall, it is typically vibrated with a vibrator in which 1 inch and above head is attached to it, and it just is dipped between the formwork to consolidate the concrete. This can be used as well for slabs, but additionally in slabs they have another machine that is called a jitterbug that you just press down the concrete as you go, and this helps consolidate the concrete in the slab. On this level, we have the ground floor parking, which would have been done as a slab on grade. In order for that to have happened, the subgrade would have had to been compacted to the specifications specified by the geotechnical engineer, and then rebar similar to what is seen here, or wire mesh, would have been installed, and then the concrete poured to the desired thickness. Here we have a cast in place concrete stair that has not been poured yet. Shown is the sub formwork made from plywood and showed below. Installed now is just the rebar, and the only thing left to do is basically pour the concrete. And as you go up, you will see a finished stair that has been done. Looking at the floor system above, you can see the concrete slab that sits on top of the steel I-beams, which are supported at the ends by either a square column or a round column, fully reinforced. Composite steel decking, as was used in most of the areas of this job, offers several advantages over the traditional cast-in-place suspended slab. For instance, the composite decking would reduce the amount of rebar that would be required to resist the tensile forces of the span and in the slab. The use of composite steel decking also allows for significant gains in the construction schedule. How? Because with the use of composite steel decking, most of them will hold up their own weight and resist the construction live load depending on the specifications. Now, with the use of this, there's no false work that will be needed, as in the case with a traditional cast in place suspended slab. Therefore, the main advantages over the composite deck versus the slab is the shoring is minimal, if even needed at all, compared to the traditional casting methods, and there's no need to remove the false work after the slab has been cast, as there's no false work there in the first place to be moved. Concrete delivery and placement. Gone are the days in construction when the concrete truck would pull up, and where the site would have been inaccessible or hard to reach or out of range of the concrete truck, workers would have to buggy the concrete in and place it wherever they needed to on the job site. With the use now of line pumps and concrete pump truck, the concrete truck just dumps the wet concrete into the trough of the line pump, and the line pump can place the concrete to the exact spot with the aid of hoses and minimal labor efforts to exactly where it needs to go on the construction site. So this saves a great deal of time and money as well on labor by just having one or two persons hold the hose and direct it to where it needs to be, rather than a ton of men buggying the concrete up to how it used to be, or hiring out a crane with a 2-yard buggy with a 2-yard dumper to place the concrete. And these line pumps come in range from a per yard per hour rate or the larger pumps. And the size of the pump needed for a job would be determined by the reach, or how far the concrete needed to be pumped, as well as how high it needed to be pumped. And the way this beam is concealed, 2 pieces of rebar are welded to the inside of the beam on the flange, and then the wire mesh is tied to that, and then the plaster goes on top of that. In this section of the main entrance foyer, you can see again another big steel beam that carries the slab, and above there started the ceiling false work, which will support the sheetrock or whatever finish they're gonna put on the ceiling. In addition, this red line is for the fire suppression that has to go in a commercial building such as this.
Ground floor block work. Before these blocks were placed, pilot holes were drilled along the lines where the walls were to be placed. In these pilot holes, rebars were placed accordingly. These rebars are also called starter bars. These bars were placed in every other core of the blocks, and every 2 rows of the blocks there were stringers run horizontally across the blocks to tie in to the other walls and into the steel columns. Also, concrete was poured in every other core where the rebars were situated. This is to add stability to the blockwork. Before these walls could be plastered, electrical and plumbing had to be installed. The walls were cut with either a saw or hammer and chisel, and the pipes were laid accordingly within the walls and sealed with the desired plastering. Wastewater piping. The floors were then drilled and cut accordingly to allow for the wastewater piping to be installed. The piping was then held up by the underneath of the floor via the method of a clamp, which was then drilled into the bottom of the floor to hold the weight of the pipe when water is passing through it. The blockwork for the elevator shaft is much different than the blockwork surrounding the building. For the elevator shaft, each core of the blocks were filled with rebars and concrete going from the ground floor straight up to the mezzanine floor. This is to accommodate for the vibrations of the elevator shaft, making sure that the wall is sturdy enough to support it.
Roofs are usually the last structural system to be constructed. There are many different types of roofs, however, the more popular ones include hip, gable, shed, and flat roofs. Roofs can be constructed from various materials such as concrete, wood, or metal, and can be covered using various types of shingles, corrugated metal roofing sheets, and even plants. Roofs covered with plants are called green roofs. Rafters, purlins, cleats, wall plates, and sag rods are some of the main structural components of most roofs except flat ones. Typical roof construction is done according to the following sequence. Metal plates, called wall plates, are installed usually by bolting onto the ring beam to ensure a flat, even surface. Ring beams are usually made from reinforced concrete. However, in steel buildings, the structural beam at the roof level assumes the role of the ring beam. The roof rafters are then installed in a vertical orientation according to the specified spacing provided by the civil or structural engineers. Rafters are connected to the wall plates via welding and to each other via bolting or welding. Metal cleats cut from L angles are installed on the rafter either by welding or bolting. These cleats provide the support for the purlins to be attached to. Purlins are then installed by connecting them to the cleats. This is usually done using bolts. If sag rods are required, they are installed next. Sag rods are metal rods which provide lateral support to the purlins, preventing them from bending, twisting, or deforming. The roofing sheets are installed after. For metal sheets, screws are driven through the sheets and into the purlins. The typical spacing for screws are 3 feet, but this spacing should be specified by a registered professional engineer. Roof workers should all be outfitted with personal protective equipment and fall arrest systems, since they are working at considerable heights. Safe access to the roof should be also provided. This can be achieved with the use of scaffolding erected by competent persons. The installation of the roof can be greatly sped up with the use of a tower or mobile crane, or simply a high-up truck. Having different teams working simultaneously on different roofing tasks will also be beneficial to the project schedule. When trusses are used, as in the case of our project, the installation process is slightly different. The wall plates are installed to the ring beam as previously described. However, the roof truss is either constructed in a factory and brought on site or assembled on the ground in a flat area. No assembly is done at a height. To ensure accuracy and uniformity, a template is usually used. The now assembled truss is then lifted and placed upside down initially. They are then overturned and fixed with temporary bracings. Once this is done, they are then aligned using lines and spread levels in smaller construction or theodolites on larger sites. Once aligned, the trusses are then permanently fixed with anchor rods at the bottom and the permanent bracing. The purlins, cleats, and roofing sheets are then installed in a normal way.
In the beginning of this video, you saw a retaining wall. That retaining wall was the support for this wheelchair access ramp, which allows those who are disabled to enter the building easily without any trouble. Here, we can also see the main entrance of the building, which also has the curved shape roof as we saw before. Also, we can see scaffolding being erected so that the final roof works can be done, which is the installation of the guttering and downpipes.
Here we see some of the equipment used on site. We have two concrete mixers that can be, well, cement mixers that can be used to either make concrete, which consists of cement, aggregate of gravel or of coarse aggregate, and sand, or as well as can be used for plaster, which is just usually consists of cement and sand for the rendering of the building, as we see here. Here we have a Cat 33C, also commonly known as a Mini X, which is used for excavating small portions when the big excavator as seen behind me, which we'll take a closer look shortly, cannot be used due to access restrictions, or it's just not warranted because of the size of the bucket. Here we have a Caterpillar excavator, model 312B, which would have been used primarily to dig the majority of the footings for this building. Crucial to any site, in addition to bathrooms, is a dumpster to carry and put all the construction waste so that it's not blowing around the project. And if you look at the shed right here, this is the on-site bathroom, which is crucial for health and safety reasons. As well as you look over here, set up in the two side office trailers is a clearly designated first aid station area.